everyone. Let's look at problem 5-1, which discusses the characteristic line and the security market line. So we'll be taking a look at beta and SML in this brief demonstration. On part 1, we're asked to use a spreadsheet or a calculator with a linear regression function to determine stocks X's beta coefficient. Then on part B, we're asked to determine the arithmetic average rates of return for stock X and the New York Stock Exchange, covering the periods given, and calculate the standard deviation of the returns for both stock X and the New York Stock Exchange. Let's cover those two first. Down below, I've placed the data that appears in this area of our problem in Excel so we can take advantage of it. Okay, what I'm going to do is simply highlight this range right here and show you how I would use a spreadsheet to do the linear regression. I will go up to the menu bar and do Insert Chart, and I know you can't see that. You see me highlighting the word chart. I picked Insert off the menu bar, and I'm going to pick a scatter chart, hit Next. The series are in columns, that's fine. Hit Next, and just hit Finish. It's going to place it somewhere on the screen. Let me shrink this because I know we don't have a whole lot of room to work with in terms of the demo so that you can see all of this. So I'll make it a relatively small chart, and that way you can still see it on the screen. I want to make sure I don't change the proportional spacings. Okay, that's pretty good. You can see that. Let's get rid of the color. I think that detracts from being able to see it. That's a little bit better. Now I'll click the actual data points, excuse me, and I'm going to click on Add Trend Line. I want linear, and I would like to know a few statistics. I want the equation and the R-squared shown on the chart. Now, that's the formula right there. We'll have to make this much larger so everyone can see it. I'll change that format. This is going to be a little bit of work. If I can get that font to be maybe a 14, maybe we'll be able to see that. There we go. Okay. So I know this is difficult because I'm only using a small amount of screen real estate. But I might be able to make this a little bit better for us. Okay, I think that's fairly legible for you all to see. Okay, so what we've done is we've provided the independent variable and the dependent variable. The independent variable would be the New York Stock Exchange historical rates of return. The dependent variable would be stock X, the one we're interested. And we've used the linear regression, and now we need to determine the stock's beta coefficient. Well, the beta coefficient is given right there, the 0.565. So in this example, we've determined on part A that for a given return in the New York Stock Exchange, we can expect stock X to hold a beta of 0.56 or 0.565. And we've got a pretty good R-squared, meaning that we've got a pretty good explanation using only these 7 data points, of course, that this is a pretty good relationship between the independent variable and our dependent variable, which is stock X. Okay, now I've moved the graph over a little bit. I still think you can see it. Let's look at part B. Determine the average rate of return for stock X in the New York Stock Exchange over the periods given, and also calculate the standard deviation of returns for both the stock X and the New York Stock Exchange. So let's calculate that. I'll go down here and I'll just write average, and I'll put in standard deviation just to label this, and I'll simply use an Excel average function. We'll list the average from up there. Copy that to there. Why don't I put a line down here so we know where the statistics start and where the data ended. Now, standard deviation, I'm going to use stdev, another function in Excel. Highlight the range. It's only that information. Drop that down, and right there I'll bold these. Those are the solutions that we need to determine the average rate of return for the market as a whole, for stock X, and what the standard deviation, which is a measure of the riskiness of stock X in the New York Stock Exchange. That takes care of the requirement of Part B. Okay, now let's look at Part C. And Part C says, assuming that the situation during years 1 through 7 is expected to hold true in the future. And what that means is the expected return of stock X is expected to equal the average rate of return, and the expected rate of return of the entire market is expected to equal the average rate of return, and both the standard deviations in the future will equal their past values. So we're really assuming a full equilibrium situation, and also that stock X is in equilibrium, and they tell us that means that it plots directly on the security market line. What's the risk-free rate? Okay, so the way we need to calculate that is through algebra using the security market line equation. All right, let me slide the screen so we have a little bit more room to work here. And I'll just slide up a little bit. Okay, so for Part C I have this formula. That's the security market line formula as it applies to this problem. And why don't we solve it off to the side? On second thought, let's solve it down below. And since there's a lot of subscript, I really don't want to type that in Excel. That will take extra time. So I'll just pull the information from another source to show how we illustrate this. All right, let me slide a little bit so you can see a little bit more. Okay, there's our security market line format. Now, what do we know? Let me slide this over. Well, we know the 10.6 comes from that cell right there. That represents the average return for stock X. We need to solve for the risk-free rate. And we know that the 12.1 right there represents the return of the market as a whole. The New York Stock Exchange is what we're using as the market, minus the risk-free rate of return, minus the beta. And we solved for beta previous in the problem, and it's the 0.565. And in our solution, we'll round that to just 0.56. Okay? So now it's simply algebra trying to solve for the unknown. So we can combine the risk-free rate of return in one term by multiplying 0.56 through it. We can rearrange the terms, right? So now we have a 0.44 times the risk-free rate of return is equal to 10.6 minus the 6.8. Hopefully you followed how I've done that. And then finally, we derive the final solution, which is 8.6%, and that represents the risk-free rate. Okay, now on Part D, they ask us to plot the security market line. Okay, well, the security market line is going to use this descriptive formula that will explain how the relationship exists between the value of the stock and the return. Okay, so y would be equal to 0.56 plus 0.086, and the 0.086 is the risk-free rate of return. The 0.56, as we know, is the beta, and we could then plot values, pick a value for x and solve for y, list them and plot them. Okay, and when you do that, you will wind up with a chart or a graph that will look something like this. Let me see if I can get this on our screen in the right way. Why don't I move this over here? We'll slide again. Then I can slide a graph of how that would look. Okay, so you'll see that where where the line crosses the axis point, well, here right at about 8.6%, and we're going to have an upward slope equal to the beta coefficient of 0.56, and that's what we would need to do to solve Part D. Then finally on Part E, they tell us, suppose you hold a large, well-diversified portfolio, and you are considering adding to that portfolio either stock X or another stock Y, that has the same beta as stock X, but it has a higher standard deviation of returns. So what they're saying there is stock X and Y have the same expected rate of return, both equal to 10.6, the average return. What stock would you choose? Well, in theory, it wouldn't matter. You'd be indifferent between the two stocks because they have the same beta, and their relevant risks are identical, and we're in equilibrium, and we're going to achieve the same results. So the two stocks would be represented by a single point on the SML. Now, stock Y does have a higher standard deviation, has more diversifiable risk, but if we have a well-diversified portfolio, we would be eliminating that risk. Okay? In practice, it's possible that stock Y would have a slightly higher required return, but the premium for diversifiable risk in this situation would be quite small. And that takes care of solving all the parts of problem 5-1.